And from a Six Sigma part, the Six Sigma perspective, the first thing that we do is, so we have to understand the current process performance. To understand the current process performance, we make a data collection. So for data collection, we make a check sheet and a data collection plan where we ask these questions: what data we are collecting, when are we collecting the data, who is collecting the data, where are we collecting the data, how we are collecting the data, and how many are we collecting the data. So these are the certain questions that we ask. So this answers to be becomes a part of data collection plan when we use a check sheet. So order fulfillment time is what we are measuring it. From when to when are we collecting for the project, when we the historical data, when we are collecting, when are we collecting those data from the process. The timeline we usually give, 15 days is being given here. Who is collecting? The name of the person or the team member who is collecting. From where are we collecting? From the order fulfillment process. How? From the CRM is a software, the customer relationship management, or an ERP system. So where we can, it can be otherwise called a software where we can do it, or it can be a document where this data is documented. So wherever the data is documented, that is from where, how we are getting this data from, measured from. How many is based on 72 samples from last 6 months. So there are different sampling size and sampling methods, which you'll study in Greenbelt. So based on that, we have to define how much sample we have to take, or how much sample size we have to take, and which sampling methods to be used. So there are the different sampling methods are there. So and different sample size methods are there. So based on that, we have to collect how many samples are to be collected from the process. So a data collection check sheet will help us to understand how much samples to be collected. So this is important. So you'll in a green file, you'll be taught more detail on the sampling methods and sample size calculations, how to do it. And based on that, we make a check sheet which help us to collect the data. Once we have the data with us, so this is how we order fulfillment time look. So it can be an Excel sheet that we can develop it, and we can use an Excel sheet and enter the data for the each data that we have taken for different months, from the 6 month, the 72 data, 12 months from each, 12 samples from each month. So that becomes our process data, which will help us to understand the process performance. So this from a Six Sigma perspective, we are trying to understand how the data is collected from the process. By this, so once we have the data, it will help us to understand the current process performance. So to understand the process performance, we call that as a descriptive statistics. So descriptive statistics describes the data. So describes the data using the mean and standard deviation. So the mean is 45.2 days. Standard deviation is 4.4 days. Histogram is where the data and the frequency is plotted. Box Whisker Plot is another way of defining or describing the data. So using graphs and statistical measures, we are describing the data. So this is how a descriptive statistics is used. So if you have an Excel sheet, so this Excel sheet is where I'll be using. So descriptive statistics. So we can know that in Excel, so when we are using, so let us, so let's say the mean and the standard deviation. So I'm just putting it STDEV as standard deviation. Mean, as you know, we can use in average is what we use it in Excel. We use it as average value. So when we look into the average is the mean, how do we calculate it? So we just want to select the columns where the average is selected. We get the average value there, 45.1. Standard deviation is depending upon what it is. So STDEV, for sample, it is S is what we call as a sample. So when we have setting 72 samples from the process, so STDEV dot S, and then select the sample, will help us to understand the standard deviation. So that is the equations being used in Excel to find out the standard deviation of a process. Now, when we want to plot the histogram, so the box plot, so in descriptive statistics, I'll be also, along with the material, I'll be also be sharing this Excel sheet. So descriptive statistics, in descriptive statistics, so these are statistics. So in descriptive statistics, so the measure, this is the mean and standard deviation is describing the descriptive statistics. And also when we look into the graphs that describes it, we usually use a box plot. And we also use the histogram to describe the data to understand the process performance. So these are the graphs being used. We're sharing this. So when we look at this, when we look into this histogram, how to create a histogram, we just want to select the column, and then we to go to insert. So in the insert, we have those options for all charts are there. So in this all charts, we can go to histogram. So this is where we can plot it. So I'll just writing, just putting the print screen so that we just want to select it. So in the selection, and then we select the histogram. So this is where the histogram is selected. So we can use the histogram. And this is how a histogram is selected. So if you want to rename it, we can rename it as histogram. So histogram is created by that method. So I just put the steps to do it. So similarly, when we want to plot, so we have to insert a box whisker plot. We have to go to insert the charts, and insert the chart, we'll get box whisker plot. So we go to that. It's called as a box plot, is also called as box plot or box whisker plot. So when we click OK, we get the histogram, and then if we add the data labels, yes. Box whisker plot. So this is how the box whisker plot is. So it has overlapped my histogram. That's why it has come like that. So it is box plot. So the box plot, when we right click and add data labels, so what we get is, so we get this values. So the values help us to describe the data. So this is where we can see that minimum time for order fulfillment is 37.1 days, and maximum is 55 days. And 45, what you see here is the mean value. So this 45.17 that you see is the mean value or the average value. So this value that you're seeing here is the 45.17 is called as the average value, or the mean. The mean or average is given there. And what you see here is 47.95, 45.65, and 41.225 are certain values that is used to understand data distributions. So one is called as 75 percentile value, 75 percentile value, or Q3, third quartile, which says that what is the value below which 75 percentage of the 75 percentage of the order fulfillment is done is called as 75 percentile. So it is called as 47.65. You can say that 75 percentages of the order fulfillment is happening in less than or equal to 47.95 days. And 45.65 is the median value, or we call as the 50 percentile value. So this what we see here is the 50 percentile value. So 50 percentile, so this called as 50 percentile value, where otherwise we call as a median value, 50 percentile or median, or it is also called as second quartile, a value below which we find 50% of the data. So we can say that in the procurement, 50% of procurement, the order fulfillment is happening in less than or equal to 45.65 days. And 41.25 is 25 percentile, or it is called as first quartile. So it is called as the value below which 25% of the data is seen. It is called as first quartile. These are certain statistical measures which help us to understand what is the time taken for 25% of order fulfillment to be completed. It is 41.225 days, and 50% of the procurement happens in 45.65 days, or called as Q2 or second quartile. 75 percentile value, third quartile, is 47.95. So these are how do we describe the process performance using these measures. So 75 percentile, 50 percentile, and 25 percentile help us to understand what is a process performance looking like for 75% of the order fulfillment, 50% of the order fulfillment, 25% of the order fulfillment, and what is the minimum time and maximum time taken for the order fulfillment. So this all can be understood by a box plot and also a histogram. Histogram is a data frequency plot. So the frequency of the X on the Y-axis, data is given on the X-axis. So it is called as histogram or data frequency plot. So you'll be also studying that how to interpret this in more details when we come to those green belt